Alright, good day class. So today we will go into the syllabus of chapter 5. Alright, analytic geometry. Okay, so 5.1 is conics. Alright, so what is conics? So a conic section, or we just call it conic, is a curve. Alright, it's a curve obtained as the intersection of a cone, more precisely a right circular conical surface. Means like this with a plane as shown in the diagram. Alright, means that it's actually the intersection of a cone, okay, with a surface. So means the surface cut the cone. Alright, so for example, let's say a surface cut the cone horizontally like this. So when it's cut, so the surface left will be a circle. Alright, so if the plane cut the cone like this, slant. Alright, so when this one move, then you will get a surface and we call it ellipse. Alright, and if the plane cut the cone like this, from here until the base, these two never touch the base, right? From here until the base, when it cut like this. So when you remove this part, then you will see the surface is like this shape and we call it parabola. Alright, and the fourth one will be hyperbola. Actually, hyperbola involves two cones like this. Alright, let's say you have two cones like this, and if you cut, alright, if you cut this cone vertically, or you cut like this, zoop, when you remove this part, you will see the surface left is two parabola, and we call it ellipse. Alright, and actually you can see the clearer picture in your textbook, page 217. Alright, you can see clearer. You see? So this one cut horizontally, plane, right? The rectangular one is the plane. Cut, then you get circle, ellipse. Okay, if you cut from the side to the base, then it's hyperbola. So if you cut, not necessarily vertically but you cut both cone. When this happens, then you will get a hyperbola. Alright? So this is how we get these curves that we call conics. Alright, so in analytic geometry, a conic may be defined as a plane algebraic curve of degree 2. See, it's a plane, right? And it is degree 2, means square. Alright? And the general equation for a conic is this one. Alright, no matter is circle, ellipse, parabola, or hyperbola. Okay, this is the general form, which is ax squared plus bxy plus cy squared plus dx plus ey plus f. This is the general one for all the four types. Alright, so of course for certain types, certain terms not in. For example, let's say circle. Okay, circle, you won't have this. Okay, the b is 0, you won't have this term. You only have these terms, for example. Alright, so this is the general form for all the conics. Alright, so after this we'll go into the specific equation for each conic. Alright, okay, so a conic can also be defined as the locus of a point satisfying certain condition. Okay, remember last lesson we talked about locus? Locus is a track that it's a track for a moving point that follows certain condition. Alright, therefore conics actually also a locus of a moving point satisfying certain condition. Alright, okay, number 5. So traditionally, the three types of conics are hyperbola, parabola, and ellipse. These are the three types of hyperbola, parabola, and ellipse. Whereas the circle is actually a special case of ellipse. Means circle and ellipse are related. Alright, and it is sometimes called the fourth type of conics. Alright, traditionally only three: hyperbola, parabola, and ellipse. Circle is the special case of ellipse. Also, we also call it the fourth type of conics. Alright, so in the old syllabus, we are more emphasized on circle. Alright, but in new syllabus, we are actually more emphasized on other three. Circle, it came out once only, I think. Alright, so the curve or the conic form depends on the angle at which the plane intersect the cone, which I show you just now in the textbook. It depends how the plane cut the cones at different angle. All right, so basically this is the introduction for conics. What is conics, right? And how it's formed. All right, so we will go to the first one, which is the easiest one, circle. All right, so 5.1.1 circles. So this is a condition that followed by a moving point so that the track become a circle. So if a moving point P, because it is moving, right? So no fixed coordinate, so we just give it XY. It's at a constant distance R from a fixed point C with coordinate AB, then the locus of P is a circle whose center is C and the radius of the circle is R. So look at this diagram. So let's say I have a fixed point, so means I know the coordinate. All right, P is moving. So no matter where P move, P can move here and there, but they follow one condition, which is each distance from the fixed point is always a constant, means always the same. Therefore, when P here, the distance from it, the distance of it from C is R. So let's say P is here. All right, the distance from P to the center is also R. So P have many, right? So when you join all these moving points that satisfy this condition, then you see you will form a circle. All right, so actually circle is the locus of a moving point at a constant distance R from a fixed point. All right, and when they form the circle, so the fixed point C is actually the center of the circle, and the distance will be the radius of the circle. All right, so now from this condition, we can form the equation for the circle. Or the condition of the locus P is CP is always equals to R, right? Then we use the CP, the equation of the distance. Remember the equation of the distance, CP. So x minus x square plus y minus y square, right? And it equals to the radius. Use the distance formula, CP equals R. Then next step is we squaring both sides. We square both sides so that this one eliminate, this one become R square. All right. Therefore, from here we get the equation of the circle, and we call this equation the standard form of the equation of a circle with center AB and radius R. Remember this one we call it standard form. It's very important. All right. All the conics, no matter circle, ellipse, parabola, or hyperbola, they have standard form. All right, and this standard form very important because if we can arrange one equation of the conics in standard form, from this form, we immediately can get the important information. For example, from here, I know that the center of this circle is A and B, and the radius of the circle is R. So standard form is very important. Okay, and remember, the standard form is x minus A. Not plus, minus, y minus B. And the center is just A and B, not negative. All right, memorize this. Okay, next, if A equal to B and equal to 0, means this one is 0, this one is 0. Therefore, the equation of the circle will become this. Because this one is 0, this one is 0, so become x squared plus y squared equals R squared. Yes, so this is the equation of the circle with center at the origin. All right, and radius R. Okay, so we will see some examples that related to this standard form. All right, so you can open your textbook. We'll look at checkpoint 5.1. So my textbook is page 220. All right, so we are going to discuss question 2 and 3. All right, so checkpoint 220, so checkpoint 5.1. Okay, question 2. We are going to discuss question 2 and 3 here. So look at this. So question 2, you're asking to find the equation of the following circles. So you are given the center and the radius, or some others info lah. All right, or some other infos, and you're asking to find the equation of the circle. Whereas question 3 is you are given 2 points on the circle, A and B. And this A and B is the diameter. All right, then find the equation of the center. So we are going to discuss these two questions. All right, so first I'm going to discuss question 2a. All right, so I think I put the textbook here so that you can see the question. All right, okay, can you see? All right. Okay, can I? So we are going to discuss 2a. So find the equation of the following circle where the center is 2, -3 and radius 4. Center 2, -3, radius 4. So we just substitute everything into the standard form. All right, so a is 2, so x minus 2 squared. B is -3, so y minus -3 become y plus 3. All right, r is 4, so r squared 16, just like that. All right. Okay, next we will see other question, which is C. Okay, question 2C. You are given the center also 2, 3. Our center is 2, 3. And the question say passing through the point 4, 4. 4, 4 is any point. It's a point on the circle. All right, so let's sketch the diagram. This chapter we use a lot of sketching lah. When you can sketch the diagram, you can see the clearer, so easier for you to answer. Okay, circle, center is 2, 3, and 4, 4 is one of the point. This circle passing through 4, 4. All right, so from here we can calculate r. I have these 2 points, so I can calculate the radius. So x minus x squared plus y minus y squared. All right, so I found that inside here is 25. Inside here is 4 plus 1. Yeah, inside here is 5. So I square both sides, because in the standard form we want r square so r equals this one, so r square, just remove the square root, so inside here is 5. So r square is 5. Therefore the equation for the circle will be a is 2, b is 3, so x minus 2 square plus y minus 3 square equals r square. All right, okay, so I'm going to discuss one more question, which is 2e. 2e. You are given the center of the circle is 4, 6, but now they tell you that this circle touching the x-axis. All right, so it's like this. Okay, so circle touching the x-axis, center given 4, 6. All right, so remember one concept that you have learned in SPM. There's one concept that you have learned in SPM. When this is, let's say this is a circle, and a straight line that touching the curve, we call it tangent, right? Okay, and remember, in a circle, if this is a tangent, touch the circle, then the tangent is perpendicular to the radius. See, radius and tangent are 90 degrees. We are going to use this concept. Remember this concept. Therefore, come back to question 2e. So this one, touch x-axis, right? And we know that the radius perpendicular to x-axis, 90 degrees. So from here, very clear, right? No need to calculate also, you see. This is y0 until 6. So the radius is 6 unit, right? Then next step, just sub in x minus 4 square plus y minus 6 square from here. And r square. So r is 6, so r square 36. All right? Okay, then the next one, I'm going to discuss G. All right, G say, you are given a circle with center 1, 2, touching a line. Just now touching x-axis, right? F is touching y-axis, so something like this you can do as homework. How about if it is touching a line? Okay, so look at this. We are using some concept that we have learned before. All right, so let's say this is a circle, center is 1, 2, and touching this line. This line is 3x minus 4y minus 10 equals 0. The equation of the line given, touching. All right, so again, we are using the concept. The radius is always perpendicular to the tangent. Touching means this is tangent. All right, and remember, last video, we have learned about shortest distance from a point to a line. Remember this? Because this is perpendicular, right? So definitely this is the shortest distance from this point to this line, right? Still remember this formula? So the radius will be the shortest distance. Therefore, you copy this line, 3x minus 4y minus 10. Then a squared plus b squared, this one. Okay, so what is inside here? Yes, the coordinate of this point. X is 1, Y is 2. So 1, 2. All right, so after you calculate, this is negative 15. That's why you got modulus become 15 over 5. So the radius is 3. So when you have radius and center, so you can get the equation of the circle. All right? Okay. Then question 3. All right, find the equation of the circle with AB as the diameter where the coordinates are A and B. So I'm going to discuss A. All right, so AB is the diameter. So again, as I say, we'll draw the diagram. So this is a circle. All right, center here. AB are the diameter. So A is 2, 5, B is 8, 13. All right, diameter must pass through the center, right? And it is the midpoint, right? C is the midpoint of AB. Because AB is diameter, C definitely that all the diameter will pass by the center, and it is the midpoint. Therefore, we are going to use the midpoint formula. So coordinate A and B. So C is the midpoint. So X plus X over 2, Y plus Y over 2. All right, so C is 5, 10. We get the center. Then after that, can you get the radius? All right, so radius is AC lah. Or you want to use BC also can lah. I use AC lah. So the radius is equals to AC. But I want R square ma. I want R square. So no square rule because after square. Okay, so I'm using AC. So X minus X square plus Y minus Y square. So I get R square is 34. All right, so with the center and the radius, okay, so you can get the equation of the circle in standard form. We are talking about standard form. All right. Okay, so your homework for this part, follow the method that I have discussed. Your homework will be questions 2, B, D, F, H, and question 3B. All right, complete this as your homework. Okay. So this is related to the equation of the equation of a circle in standard form. All right, next. So we have another form to represent the equation of a circle. So as well as being able to write down the equation of a circle given in its center and radius, it is equally important to be able to recognize an equation as that of a circle. So means that if the equation of a circle expressed in other form, we also must be able to recognize that, oh, it is a circle. All right? So now we are going to see this. All right? Other than standard form, how we can express an equation of the circle in other form. All right. Okay, so let's say expanding and simplifying the equation of a circle with center A, B, and radius R. All right, so this is the standard form. Then next step is we expand it. We expand the quadratic. So x squared plus a squared minus 2ax. So y also the same. Y squared plus b squared minus 2by. Or r squared. Alright, then we just rearrange. So x squared, y squared. So when we write the equation of the circle in this form, we will normally write x squared, then followed by y squared, then followed by any terms in x, and followed by any terms in y. Okay, then we group all the constant. So a squared, b squared, and r squared shift here, so minus r squared. We write in this. Okay, after expand, we rearrange in this form. Then compare to this. Compare to this. X squared plus y squared plus 2gx plus 2fy plus c equals 0. So when we compare this one to this one, alright, so we can see that g is actually equals to minus a, right? 2 and 2 same, x and x same. So g is equals to minus a. Okay. Then b is equals to minus f. F is equals to minus b. This one. Alright? Whereas c is equals to this whole thing. Okay? Therefore, when I rearrange this, r squared move here. So my r squared equals to f squared plus g squared minus c. Okay? So after we compare, we get this. Okay, now we rearrange. Therefore, from here we see that, what is the a? What is the A here? Yeah, A and B are the center of the circle, right? So therefore, from here I can say that A is equals to negative G, B is equals to negative F. Alright, so from here, even from here also we can get the center, which is negative G, negative F. This one. Okay, center. And the radius, we have to calculate lah. The radius will be F squared plus G squared minus C. Alright, so we call this general form. Alright, the equation in this is called general form. So remember, this is standard form. Standard form is easier. Directly we can see the center and radius. Alright, and this one is general form. General form also we can find the center and radius. Alright, but you must memorize the general form lah. Is 2gx 2fy. Okay, so the center is negative g, negative y. Alright, and the radius is, you just calculate this. You just calculate this. Square root f squared plus g squared minus c. C come from here ma. Okay, of course provided this thing must be positive lah, or else square root negative, it become complex number, right? So if, let's say you really get this thing is negative, means this is not a circle. Alright, so remember, for circle, two important formula, standard form and general form. Alright, both also can find the center and the radius of the circle. Alright, other conics also have these two forms. Later we will go through one by one. Okay, therefore, the conditions for an equation to be a circle. So when they are given you one equation, so how I know it is a circle? Yes, there are some properties that you can see from it. The first one is, it is a quadratic equation, means degree 2 lah, in x and y, degree 2 lah, and does not have term in xy. You see? No xy. Only x square, y square, only x, only y. There is no xy. Remember this one? Like this. There is no such term. Alright? Circle, no xy. When you see got xy, then definitely it's not circle. Alright? So the first condition is, you have x square, y square, and does not have xy. Alright? So other than this, the second property is, the coefficient of x square and y square are equal. The number in front of x square and y square must be the same. Then only it is a circle. If it is not the same, let's say it has x square, it has y square, and then no xy. But if the coefficient of x square and y square not the same, then it is not circle. It is ellipse. We will see later. Alright? And the third one is, the radius is this one. So means the f square plus g square minus c must be positive. Then only it is a circle. So three properties. Alright? Three properties to define an equation given to you is a circle. First, it must have x square, y square, and does not have xy. Second, the coefficient for x square and y square must be the same. And third, f square plus g square minus c must be positive. Alright? So this is how we recognize it is a circle. Okay, so next, to find the center and the radius of a circle from its equation. Let's say you are given one equation in this general form. How can I find the center and the radius? Okay, we have two methods to do it. Alright, so first method is, we express the equation in the general form. Then, after that, we can recognize the center is negative g, negative f. And the radius is this one. Just calculate only. And the second method is, we are going to use completing the square. Alright, use completing the square to express the equation in general form, become standard form. Yes, from here, become like this. Once it's in standard form, then immediately we know the center and radius. Alright, so I'm going to discuss both the methods. Alright, so again, we will go back to checkpoint 5.1, page 220. Okay, I'm going to discuss question 1, 4, and 5AB. Not all, I will choose one. Okay, so look at your textbook. So question 1. Okay, so I'm going to use first method first. First method. I'm going to discuss some question that using the first method. Okay, so question 1 is like this. find the centers and the radii of the following circle. So they're given you in general form. And they want you to find the center and radii. Radii is the plural form of radius lah. Alright? So I'm going to discuss 1A and 1D. 1A and 1D. Alright? Okay, so look at this. I push a bit earlier. Okay. Alright. Okay, so question 1, using the first method. Using the first method, we rearrange in this, follow this general form. Then from here, we can get our center and radius. Okay, so 1A, you are given this equation. X squared plus y squared plus 4x minus 2y minus 15 equals 0. Okay, so remember, the general form is like this. It must in the form 2gx, 2fy. So you see, I rearrange again. So x squared, y squared. This one must be in 2gx. And this one must be in 2fy. Alright, this one just copy lah, see. So, what am I going to fill it here? So that you get back 4. So, it's 2, right? Yes, 2 times 2, 4. Okay, what am I going to put here? So that you get negative 2. So, it's negative 1. Right? Then you get your negative 2y. Yes, it must be in the form 2gx, 2fy. Alright, so after we write in this form, the center is negative g. So g is 2. So negative g is negative 2. Alright, then negative f. So f is negative 1. So negative 1, 1. Yes, so the center is negative 2, 1. Alright, and the radius will be, remember just now we say, radius is f squared plus g squared. So f squared plus g squared minus c. F squared plus g squared minus c. Your c itself is negative 15. Alright, then you calculate. So 1 plus 4, 5. 5 plus 15, 20. 20 is 4 times 5, right? 20 is 4 times 5. So square root 4 is 2. So 2 third 5. 2 third 5. We always express in exact form. We don't want decimal. Alright? Yeah. So if the equation given you in general form, how we can find the center and radius? Just like this. You write it back into 2gx and 2fy form. Alright? Okay, D. So D, the equation given to you is x squared plus y squared minus 20y plus 336. You see that? No x here. No x. Never mind. We still write it in the general form. So x squared plus y squared plus 2gx plus 2fy plus this 36 lah. Still write it in the same thing. Same type. Okay, so no x, right? No x means your g is 0. That's why no x. So it's 0. Okay, what else? F. 2fy. This is negative 20. So means I have to multiply negative 10, so that you get back your negative 20. Yes, so from here you get your G and F. So the center is negative G. So G is 0 so still 0. Okay, F is negative 10. So negative F, negative 10, 10. Yes, so the center of this circle is 0, 10. So it's okay that if no X or no Y. Means that the center of one of the coordinate is 0. Okay, next will be find the radius. So f squared plus y squared minus 36. So this is 100. 100 minus 36 is 64. So square root 64 is 8. So the radius is 8. Alright? It's not difficult, but just memorize the standard form and the general form. Alright? Okay, so next one will be D. Okay, question 1D. You can see. Alright. So question 1D, you are given this 2x squared plus 2y squared plus 3x plus 4y plus 2 equals 0. So you see or not? X squared, y squared. And the coefficient for x and y, same. So I know this is circle. Okay, but the general form, remember the general form. Okay, the general form, the coefficient for x squared and y squared is 1. Then only we can find the center. So this one is 2. So to simplify it, to make it become 1, I multiply the whole equation by half. Alright, so 2 multiply half, you get this, you get this. 3 multiply half, 3 over 2. 4 multiply half, 2. 2 multiply half, 1. Yes, you must write it in the general form. This is the actual general form. Okay, then again, we write in we find 2gx and 2fy. Okay, so 2 multiply what? You get back your 3 over 2. Have to think. Okay, 3 over 2 multiply what? So 2 times what? You get back your 3 over 2. See that? Times what? Alright, so we want to find this. So this what is, so multiply 2, shift here, divide 2, right? So 3 over 4. Okay, so inside here is 3 over 4. It's true, right? 2 and 4 simplified, you get back your 3 over 2. Alright, so this one no problem. 2 times 1. Okay, so after that, the center will be equals negative g, remember? Negative g, negative f. Alright, okay, radius, f squared, y squared, g squared minus 1. So this is 1. 1 minus 1 no more. So 3 over 4 square and square root. So the radius is 3 over 4. Okay. Right? Okay, so this is question... Sorry, it's not 4D. It is not 1D, it's 4D. It's 4D. 4D. Okay, not 1D, 4D. Okay? Because question 1, in question 1, from A to F, all are in this form already. So I use 4D. It is 4D, Okay. So just now is first method. Alright, so means we rearrange the question in general form. So from there we get our G and F. So can get our center and radius. Alright, so second method will be, we are using completing the square. Alright, so I am using question 4 to discuss completing the square. Use the method of completing the square. Alright, so this is question 4. Write down the center and radius of following circle. Means you are given general form. This one also can consider general form but if you want to get center, then it must be 1. Okay, so they want the center and radius. So completing the square means we are going to express the equation in general form to become standard form. So we need to completing the square. Alright, so let's see 4a. Okay. Alright, so let's see 4a. So you are given x squared plus y squared minus 4x minus 6y minus 3 equals 0. Okay, so to do completing the square, we group x and x together. Just rearrange only. This step, just rearrange. Then y and y. Okay, so all the constant move to the right hand side. Okay, so this step just rearrange. Okay, the next step is completing the square. Alright, I'm going to do completing the square for x squared minus 4x. Alright, so it is x minus 2 squared. So you see x squared minus 4x. See? But I have one extra 4. Negative 2 squared is positive 4. This is something extra that I don't have in the original equation. So I have to minus it out. When you expand this thing, you have plus 4. So plus 4 minus 4, no more. Remember this step. Then this one also. Y squared minus 6y. Completing the square is y minus 3 squared. You see, y squared. 2 times this one times this one, negative 6y. Alright, then again, when I expand, I have positive 9. It's something extra, right? So I minus out. Alright, I minus out the 9. So it becomes equal to this thing. Alright, then just copy. This is x minus 2 squared, y minus 3 squared. Minus 4 minus 9 is minus 13. So minus 13 shift here is plus 13, so 16. And remember 16 is also 4 square. Alright, so this is in standard form. So you see, at first general form. Then we do completing the square. We express it in standard form. Alright, so already in standard form, so no problem for you to find center. So remember, standard form here must be minus. So your center is 2 and 3, and your radius is 4. Standard form. Okay, remember, standard form must be minus here. These are the things that you must memorize. Alright, okay, then 4e. Okay, so 4e, you are given the equation like this. 3x squared plus 3y squared minus 9x plus 4y plus 6 equals 0. Alright, so again, x and x I write together, y and y I write together, constant, move it to the right hand side. So to do completing the square, we know that cannot be 3x squared, it must be 1x squared. So I factorize out 3 lor. And y also the same. I factorize out 3, so it become like this. Now only you can do completing the square. So this 3 just copy. So this one, completing the square is x minus 3 over 2 and square. So you check. X squared. 2 times negative 3 over 2. 2 and 2 simplify, right? So minus 3x. Okay? Then, again, after square this one, I have 9 over 4. It's something extra. So I have to minus out. Alright? So for the y part, also the same. Completing the square is like this. Y plus 2 over 3 square. So y squared. 2 times 2 over 3 is 4 over 3. Then again, this one after square is 4 over 9. Something extra, so I have to minus it out. Okay, then I have to multiply the 3 inside the big bracket. So 3 multiplied inside here become like this. 3 multiplied this one is this one. This one also 3 multiplied. You write like this, don't multiply inside here. Then 3 multiplied this one is this one. Okay. So the constant, minus 27 over 4 minus 4 over 3, shift it to this side. Then you get 25 over 12. Alright? And we don't want 3 here, right? So both also got 3, so the 3 we move here. So times become 36. Alright? So now this is in standard form. Alright? So standard form, therefore, the center is, remember standard form must be minus, minus. So this one minus, so it's 3 over 2. This is plus. So plus means minus negative, right? So the y is negative 2/3. Okay, so the center is 3 over 2 and minus 2/3. Radius, so this is r squared. This is r squared. So square root is 5 over 6. Okay? So this is how we use second method. First method and second method. Alright, to find the center and the radius for the equation of a circle then given to you. Okay. This question 4 and 4. Alright, so question 5a. Oh, no. Questions 5a,b. Find the equation of the circle. Oh, okay. Oh, this one I haven't done. Okay, it's okay. I still can do it. Alright. Alright, question 5 is like this. Find the equation. Question 5, you are asking to find the equation. But okay, no. It's okay. Hold on, let me see. Okay, if which is in this way, 3 points, center. Okay, no. We forget about it. I don't know why I put it here. No need. Alright, so okay, so question 1 I have discussed. Okay, question 1 I have discussed A and D, right? Question 1 I have discussed A and D. So you choose another 2. Please choose another 2 to do as your homework. Alright, and question 4 I also have discussed too, which is A and E. Okay, so you also choose any 2 as your homework. Okay, so your homework is question 1, another 2 questions, and question 4, another 2 questions. Alright, so today's lesson I will stop here. Then the next day I will give you another one. Okay, thank you class.